This is video 5 for Computer Science 3344. We are talking about context-free languages, or we were. We've looked at grammars a little bit, but as you know, we spent most of the semester so far on machines. Things like the NDFAs. Remember those? Man, that seems a long time ago. What's the relationship between NDFAs and regular languages? Oh, as if I only have to ask. You know what? I'll switch color for this. NDFAs, finite automata, love regular languages. There's another loving relationship we need to take a look at. Who loves context-free languages? Well, that's what I'm talking about today. Pushdown automatas. Starts with a P. PDAs. Pushdown automata. Got the same last name. Same kind of abstract machine. Automata. Something about it must be automatic. Except this is not necessarily, well, it is finite state, that's true, but it's got something else. Pushdown, it's got something that the other one didn't have. I bet you can guess. Our working definition, it's a formal definition that I'm not terribly formal about, so I'm going to call it a working definition. A PDA, pushdown automata, is a 7-tuple. Unless you're reading through in Sipsert, he's got a 6-tuple. I've got an extra piece because that's how I was raised. It's a finite automata machine with something extra. Capital M for machine. It's got all these pieces, the 7-tuple. Capital Q, capital sigma, capital gamma. G for gallows. Looks like the hangman thing, doesn't it? That's a capital gamma, little delta, Q0, dollar sign. Dollar sign is what's missing from Sipser. I'll try to remember that when I actually get to that piece, which will be a while from now, as you can tell. And capital F, where all these pieces mean all these things. Capital Q, set of states. That's nothing new. We've seen capital Q before. I'm going to put in one line here to save board space. Capital sigma is, whoops, not equal, colon. That's our input alphabet. We're still going to be reading strings. We're still going to be deciding yes or no, is this string in the language? It's got to be a little different because the languages are different. The languages are context-free languages rather than regular languages, but it's still got to be made up of input symbols. That's what capital sigma is. Here's a new one, capital gamma. Capital gamma is a stack alphabet. And I can see you smiling and nodding through the internet, through the interwebs. You knew there was going to be a stack. That's why it's called a pushdown automata. We're going to stick a stack on our finite automata so that we can remember stuff. That's what the finite automata, finite state automata, just the vanilla version, that's what it was not able to do. If you remember, it wasn't able to remember things. Let me just keep going. Who's next? Little delta. That's our state transition function. I'll just call it the transition function. And if it's a function, it's got to have a domain and a range. It goes from these things, Q, cross, and then in parentheses, capital sigma, union, the symbol for the empty string, close parentheses, cross, parentheses again, capital gamma, whoops, not a colon, I've already defined it, union, the set contains just the empty string, the empty string symbol, excuse me, takes an element of that to an element of this, the power set of Q, cross, capital gamma star. And we can all say it together. Yikes! What on earth is that stuff? Well, those crosses, those kind of give it away. Let's count the crosses here. We've got 2, so it's going to take a 3 tuple of something, an ordered triple, and take that to a set of things. A set of what things? A set of ordered pairs. We'll do the easy part first. Set of ordered pairs where the first thing is a state out of our set of states, and the second element of an ordered pair is going to be a string of stack alphabet symbols. That seems kind of weird. What about these ordered triples? The ordered triple is, this is a state, then comma, and then we've got, in the general case, we've got an input symbol. Or, here's a weird one that we didn't have in finite automata. Well, we had that, yeah. Epsilon arrows. We had epsilon arrows. Oh, yeah, what was I thinking? So either it's going to be a state, comma, and then an input alphabet symbol, or the epsilon character. And then the third piece is going to be a stack symbol. So all we got to do is figure out what that actually means. I'm going to switch color for the interpretation, because it's not technically defining what those pieces are. Interpretation, abbreviated. The machine looks at, it's going to decide what to do next, but it's got to look at stuff to decide what to do next. Looks at the current state, it looks at the next input symbol, and the symbol on top of the stack. Now, where did I get that? I wasn't even looking at my notes when I wrote that down. Input, stack, I guess those are the words and such. I got it from right here. Machine looks at the current state. An element of Q is the current state. The next input symbol, that's an element of capital sigma. That's our input alphabet. And it also looks at the symbol on top of the stack, which has to be one of our stack input. No. One of our stack alphabet symbols. It's not input. The stack is like our own little stack in the back where we store things so that we can remember them later on. So the machine looks at all that stuff and then moves to a next state. And here's the weird part. And it replaces the symbol, the single symbol on top of the stack. This is not start. And replaces the top of the stack symbol with a string of stack symbols. That sounds really weird. Once we get into a few examples, that's going to make a lot more sense. Okay, then moves to a next state and replaces the top stack symbol with a string of stack symbols. All of that is just interpretation of what I wrote for little delta here. Let me read this back, see if it makes any sense to me. Interpretation of all this gunk right here. The machine looks at the current state, the next input symbol, and the symbol that's on top of the stack. And then little delta says, okay, now we're going to go to this as our next state, and I want you to rip off that symbol you saw on top of the stack and replace it with this string of symbols. It's 0 or more symbols. We could replace it with nothing, also known as popping the stack. We could replace it with nothing, or we could even replace it with multiple symbols. I'm suggesting that's the weird kind of thing about that we can replace it with several things. But the green stuff is trying to explain all of that right there. That still leaves me some pieces out of my 7 tuple to go. Pardon me. Oh dear, am I going to have space? Q0, Q0 is the initial state or start state. Your choice of term. They mean the same thing. Who's next? $sign. That's a new one, and actually that's what Sipser leaves out. If you're looking at the official textbook for this course, he has a 6 tuple, but I like the ones that use a specific symbol to say, you know what, you've reached the bottom. That's the initial stack symbol or the bottom of the stack symbol. I'll just call it initial stack symbol. It starts off there. Dash, and then I'll describe it. It's almost like a sentinel value in a way. Is that how I want to think of it? Why not? Initial stack symbol. This marks the bottom of the stack. And one left. F is not a single state in general. That's a set of final states. If we get to any one of those, we're in good shape. Set of final states. Or also known as accepting states. If we get there, we accept the string. And maybe it goes without saying, but I'll say it anyway. Of course, F is a subset of Q. Q has all the states in it, the initial state, the final states, all that stuff, and everything else we might go to. And that filled out the entire board. Any questions? Well, take your snapshot of that or copy it down, because now I'm going to have to erase all of it to make room for anything else. Nice weather we're having today, huh? This is actually the second start to this video. There was a bark fest the first time I started it, and I had to discard that. There. I made small talk for the time it took to erase the board. Another working definition with hopefully a juicier black marker if I haven't used up all of them. A configuration of M. C-O-N-F-I-G-U-R-A-T-I-O-N. A configuration of capital M. That machine we just talked about one whiteboard ago. Looks like this. It's in parentheses. It's an ordered triple. Q, comma, W, comma, alpha. Where these pieces are these things. Q is the current state. Now, if you're wondering in general what's a configuration, it's like a snapshot of where the machine is right now. It might be at the very beginning, it might be at the end, it could be anywhere in between. But a configuration is just one of the days in the life of our machine as it's going through trying to figure out whether the string is in the language or not. W is the remaining input. Double underline that. At the beginning, it's going to be the entire input string, but just as with our NDFAs and DFAs and all that stuff, you eat up one symbol at a time, and once you've eaten up that symbol, it's gone. You can't go back and look at it again. So anything we're going to need to know, this is a projection forward, anything we're going to need to remember about an input symbol that we're looking at right now, we're going to have to put it on our stack so that we can remember it. Aha, aha, I gave away the key to this thing. And I'll just put a note here parenthetically. Our input is consumed left to right, one-way trip. And to browbeat you about it, just like an NDFA. When we're eating up a string in an NDFA and going through all our state transition diagram and everything, we use the symbol exactly one time, and then we don't go back. There's no way to get it back once we've used it up. Alpha, and this is a new piece. Alpha is the entire current stack contents. So the stack is a player in this as well. We've got not just a current state, not just the input string that we haven't used up yet, but we've got the entire current stack contents. And unlike the input string, which is a one-way trip, so it's going to be shrinking and shrinking and shrinking as we go from one configuration to the next, the stack could grow and shrink and do any kind of stuff back and forth. Because remember, when we're going to put something on the stack, we can actually put a string on there to replace the single input symbol, so it might grow significantly. And I'll put parenthetically here, where left to right double equals, C++ double equals, left to right means top to bottom. So the top of the stack is whatever the leftmost symbol is in our configuration of alpha, top to bottom. Okay, that's a configuration. Based on that definition, again a working definition, a computation of or on a PDA, a pushdown automata, is a sequence of valid changes in configuration. I'll underline that. I'll make that F a little bit cleaner. A computation of a PDA is a sequence of valid changes in configuration. So where this is a snapshot, this is like a single frame of your movie. This is the whole movie. This is that whole sequence of snapshots that shows what happens as you're trying to eat up this string and recognize it as being in the language or not. Okay? Now, even though I didn't fill up the whole board, we've got lots of definitions. We got lots of stuff about the machine itself, and I don't have a single example, and it's actually going to take a little while to get through the example, so I'm not going to start that. I'm going to go ahead and chop off this video, and the whole next one will be the whole example. So that's the end of video 5. I'll see you online.